Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, and we have a wonderful binomial expansion problem that we are going to solve here. Okay, so consider this expansion. It's to the 8th power, and they give us the first couple of terms, and then they give us another term down the road a bit. And the first thing they do is ask us to find b right here. Okay, so this really isn't too horrible. Um, let's just think about this particular binomial expansion. The first term here, this is the first term, and this is the second term. Okay, so the first term would 256x to the 24th power would be calculated using 8 choose 0 times the first term, 2x cubed to the 8th power, times the second term, and we hardly ever write this, and you'll see why in a second, b over x to the 0 power. We don't write this because anything to the 0 power is 1, so this whole thing is equal to 1. Okay, so the b is gone, but we know that that is equal to 256 x to the 24th. But that does not help us find b because the b disappears. So we're going to use our second term. Well, our second term is given by 8 choose 1. So that's going to be 8 choose 1, 2x cubed to the 7th power, 8 minus 1 is 7, times b over x to the first power, which I am not going to write. And we know that that is equal to 3072 x to the 20th. And if we want to make sure that we're correct, let's make sure that we end up with x to the 20th when we simplify this. So this would be 8 choose 1, 2 to the 7th power, times x to the 21st power, times b, and that would be all over x, and that equals 3072 x to the 20th power. And if you simplify that, x to the 21st over x, 21 minus the exponent 1 here is going to be 20. So we would have 8 choose 1, 2 to the 7th, x to the 20th, b is equal to 3072 x to the 20th. Well, the x to the 20ths, you could divide both sides by x to the 20th. Anyway, same thing on each side of the equation, gonzo, they're gone. Okay, so now I have 8 choose 1, which is 8 by the way, but I'm just leaving it there because I want to show you how to do it on the calculator. 2 to the 7th, b is equal to 3072, which means that, we'll go over here, b is equal to 3072 divided by 8 choose 1, 2 to the 7th. In other words, how many ways can you choose 8 objects one at a time? Well, that's clearly 8. But ow, I just hit my knee in case you care. Let's go ahead and figure that out. So that would be, I love the fraction thing here, 3072 divided by, now you can either type in NCR using your keyboard here for the choose, or you just simply go menu, probability, combinations, and it was 8, comma 1, and we're multiplying that times 2 to the 7th power. Boom chakalugala, and we get 3. Okay, and just to prove to you that 8 choose 1 is 8, 8 comma 1, booyah. Okay, so you didn't have to type in, if you know 8 choose anything, choose 1 is the anything, but I just wanted to show you where you can find your n choose r. So anyway, b equals 3, so we've got that done. Okay, b equals 3. Okay, and I am going to copy this and go to a new page. Oops, nope. Go to a new page. because I ran out of room. And all we need for part B is that we found in part A that B is equal to 3. Okay, so now we have to find K, and our clue here is K is the coefficient of x to the 0 power, and when x to the 0 power, or anything to the 0 power, is equal to 1 except for 0 itself. So another way that they might ask this is to find the constant term. Okay, same thing. When you're asked to find the constant term, you're looking to find when there is no variable. So you're looking for the variable to the 0 power, and in this case, x. So there's a lot of different ways to think about it. Once you have an established pattern for the exponent of the variable in the expansion, that pattern continues. So this is the first term. This is the second term. Okay? And remember, the first term, the hardest thing, and not the hardest thing, the first term is 8 choose 0, yes? And the second term is 8 choose 1. Let's just keep that in our back pocket for a second. Okay, so let's forget about this one for a second. The third term is going to have some coefficient which I don't care about. So it's going to be some coefficient and then x to the 16th power because the exponent is decreasing by 4. So the fourth term will be x to the 12th. The fifth term will be x to the 8th. The sixth term will be x to the 4th. And the seventh term finally will be x to the 0 power. Okay, x to the 0 power. Well, look at the relationship. This is 8 choose 0, and it's the first term. 8 choose 1 is the second term. 8 choose 2 is the third term. In other words, the term is always one more than what the second thing is. So since it's the seventh term, this is going to be 8 choose 6. I mean, you could figure that out. 8 choose 0, 8 choose 1, 8 choose 2, 8 choose 3, 8 choose 4, 8 choose 5, 8 choose 6. So the term that has x to the 0 power is 8 choose 6. And we'll be able to verify that. You'll see that here in a second. So 8 choose 6. Okay. So my 2x cubed is going to be to the 8 minus 6, or second power. I should have shown you that in the previous slide, that to the 7th power. In fact, I'll show you. See, this was 8 choose 1. This is to the 7th power. You can think of that as it's n choose r, n minus r, or 8 minus 1 is 7. So that's always the case when you expand a binomial using the choose. Okay, so that's 2x cubed squared multiplied by b over x. Now we know that b is equal to 3, so instead of b, I'm going to put in 3 over x, and that's going to be to the 6th power. For two ways you can think about it. This guy is always the same as r, and choose r is the way we talk about chooses. Or you know that the exponents must always add up to 8 just because of the nature of the expansion. Okay. And we know that this is equal to, or we hope it's equal to kx to the 0 power. And if you're nervous, you can just work, you can simplify this and make sure that you end up with x to the 0 power here. So let's do that. You don't have to, but you can. So we have 8 choose 6, and so this would be 2 squared times x cubed squared is x to the 6 times 3 to the 6 over x to the 6, and we want that to be equal to kx to the 0. And I'm going step by step here. Forgive me, I don't mean to be insulting, but I just want to make sure you understand. 8 choose 6, 2 squared, I'm going to go ahead and get crazy and write that as 4, so that's times 4. X to the 6 minus 6, there you go, boys and girls, times 3 to the 6 equals kx to the 0. And clearly we're going to get 8 choose 6 for x to the 0 times 3 to the 6 is equal to kx to the 0. So you can see that we got the x to the zeros. And what's happening algebraically is those guys are canceled out. So we end up with 8 choose 6, 4 times 3 to the 6. Don't you dare say that equals 12 to the 6. Remember your order of operations. Exponents come before multiplication. And that is going to be equal to k, or the constant. So again, let me re-emphasize. They could say find the constant term. Instead of having any of this, they could have gotten rid of this and just said find the constant term. And it's the exact same question. Find the constant term. It's the term without any kind of variable because the variables go away. Okay. So now we just go to our handy dandy calculator. If you want, you can arrow up twice and put in the 8 choose 6 since you already have it in there. And I forget what that's going to be multiplied by, times 4 times 3 to the 6th. So get back to my calculator, times 4 times 3 to the 6th. Bam, and we get 81,648. So that means 81,000. I forgot it. How horrible am I? 648 is equal to k. All right, that is it. I hope you enjoyed it. I know I did. I am out.